Hello everyone, this is James Fredrickson. I'm creating this video for Engineering 100, module number 12, Engineering Graphical Communications, Drawings and Symbols. This video is supposed to help you with your assignment number 12. So I'm going to be going over a portion of the PowerPoint presentation, but just a portion of it, so please make sure that you read the rest of it. And we're going to start off with this slide. It says the importance of engineering drawing. It says a picture is worth 1,000 words. Notice it's in red. It says in engineering, a good drawing is actually worth more than 1,000 words. The next thing that I'd like to talk about are orthographic views. So you can see that we've got some block that has a hole in it with kind of a step down shoulder here. And I'd like to explain how to unfold this box. So typically, the most important view, which I would call the front view, would be this one right here. We would place right here and we would label it as front. And all the other views rotate off of this. And you can consider this edge of the box a hinge point. So that's the same as this edge. This edge right here is the same as this one. When you, if this is the hinge point and the rest of this is cut away, you actually take and you flip it up at the hinge point. So that tells you which direction to rotate the view. So another hinge point here, you hinge it to the right, you hinge it to the left, and if you hinge it to the left again, you actually get to look at the back of it. So anyway, this is how you do it. Make sure that you view each one of these edges as a hinge point, and you probably won't have too many problems with it. Let me explain what some of these lines are. These are solid lines, so they depict the edges of a part. The hidden lines right here, they actually represent the quadrant of this circle and the quadrant of this circle. So in this view right here, you can't see this circle, but if a machinist was working on it, he would want to know that there was something there so he didn't actually drill into this surface. So you're going to see him here as well. This line right here depicts this edge of this quadrant. This line right here depicts this quadrant. This line right here, since we can't see it in this view, actually depicts this solid line right here. So if you were going to create this part, or send a print to the machinist, how many of these views would you have to send him so he could make the part? Well, certainly not all of them, so let's take a look at the next slide. And so here's the part with the most important view, which is the top view. We've added another line type. The line type is a center line. So this line right here with a short dash and a long dash and a short dash represents the center of the circle. So you can see it's also present in this view. Once again, we've got hidden lines on either side. They represent the quadrant. So the front view here is very important. So I definitely need this view for the machinist to machine this part. The right-hand view tells me the width of the part. And the top view shows some additional detail, but I'm thinking that I could actually eliminate the top view and I could make that part without the top view. But a lot of times people will put in a top view just so the machinist has quite a bit of clarity. So anyhow, what happens if we eliminate this? Well, we know how tall it is, right? We know how wide it is. This width here is the same as this width here. I know where this location is, so I don't need to know it here. So once again, you could make this with only two views, and it would have to be this view right here and this view right here. Another important aspect of this drawing is to line up the edges. So after you draw the front view, if you were drawing this by hand, you would lay a straight edge on this edge right here and extend it all the way up. So when you started drawing your top view, this edge right here would be even Steven with this edge right here. The bottom edge right here needs to be even with the bottom edge right here. So you want the top view directly above it. You want the right-hand view to the right-hand side of it. Let's take a look at these two parts that have been drawn. This could be a gasket for a car, and this kind of looks like a sewing machine spool. This part right here, let's just say it's a gasket. This would be, of course, the front view, and it shows you everything that you need to know about the part with the exception of the thickness. So you could actually call out the thickness of the material in the title block, and you would not have to draw the side view of it. A lot of times people will do that, and it's certainly not wrong. But you wouldn't want to draw the side view here and a side view here and a side view here and then flip it and draw the reverse view of it. It's needless and a waste of time. This drawing right here, if this area right here is our front view, this would be our side view. So you need a front view and a side view. If you were to draw the top view and you were to draw the bottom view, the top and the bottom and the front view all look exactly the same. So once again, it's a waste of time. So over here on the right-hand side of the screen, we've got an isometric drawing of a block. And over here, we've got the front view and the side view and the top view. Now, when I look at this, I would have said that the top view was actually the most important view. And I probably would have labeled that my front view, and then I would have drawn the other views accordingly. But they've chose to do it this way. So anyway, how many views do you have to have in this drawing to make this part? Well, let's take a look. So if you draw it like this and you draw the front view with just a hidden line, I believe you're going to have all three of these. Let's see. No, you could probably still do it with two different views. You could do it with this front view because it tells you how high the block is and how wide it is. And you could do it with the side view because it tells you how deep it is, and then it shows this detail right here. So you could actually do it with two views. I would have probably drawn it with this top view and this side view in a different orientation, and I would have forgotten about the front view. But there's some give and take here, so you get to decide on your own what the most important views are. The next thing that I wanted to talk about was the difference between location dimensions and extension lines and center lines. So location tells you the location of an item, right? So this says location. If it was, say, 2 inches from here to here, you would actually see 2.000 up here. It tells you how far it is. If we had lots of other things in here that we had to dimension, we would want to make room for them. So these extension lines that are rather short right here, you might have to stretch it on up so you'd have a space available to put additional extension lines to dimension other items that were in here. So once again, location. This one says size, so it gives you the overall size of the part. And what type of line is this right here? This is a center line. And lastly, let's take a look at one more drawing. I just want to point out once again that the front view is typically the most important view. So here's our front view. We've got lots of hidden lines. You've got hidden lines here, hidden lines here, hidden lines here. These hidden lines right here correspond to this cutout right here. These hidden lines right here and here and here and here correspond to the quadrants of these circles. Notice that this edge right here in the front view is perfectly lined up with this edge in the top view. The bottom edge right here is perfectly lined up with the bottom edge in the side view. And also at the top. So anyway, make sure that you line your views up accordingly. If you were to take the side view and push it up, it would be in the wrong location, and it will be counted wrong when you turn in your assignment. So make sure that you do line up your views. So anyway, these are our orthographic views. This over here is an isometric view. If I were to draw an imaginary line horizontal here and it touched the corner of this isometric view, the angle from this edge down to the imaginary line and the angle from this edge down to the imaginary line would be 30 degrees. The next slide that I want to show you is just what I was talking about before. This once again is an isometric drawing. It's a block, and look, it's 30 degrees and 30 degrees. So once again, if I drew that imaginary line across the bottom here, the angle from here to the imaginary line and the angle from here would be 30 degrees. So anyway, when you draw an isometric drawing, you need to make sure that you have a triangle that has 30 degrees on it. You can purchase a 30, 60, 90 triangle for pennies. So you're absolutely going to want to use one if you're going to draw this by hand. Anyway, draw your lines at 30 degrees. So the vertical line depicts height. This would be the height. This would be the depth. That's how deep it is here. And this is the width, right, from here to here. So if you do this on graph paper, and it's 5 units deep, so make sure it goes 5 units here. If it's 3 units high, make sure that you show it as 3 units high. You want to draw it to scale. It makes things much easier, and you get a much more beautiful looking drawing when you're finished. Here's a typical way of how you might draw this part. So you might start off with just a box. So you rough the part out. Here's the height of it. So here's the height. You make all sides of the box the same height, the depth, and the width. And then what you end up doing is you draw the other box, the one that you want to erase, then you just erase the lines that you don't want. But once again, make sure you draw it to scale. It makes things much easier. All right, the next thing we're going to do is we're going to scoot on to the assignment. Okay, so let's take a look at assignment number 12, engineering drawing. And let's take a look at right up here. So here's the initial drawing, and we're going to call this our front view. And there's some dimensions that are laid on it. So it says that it's 8 inches high, and it's 12 inches wide, and it says the end is 8 inches square with an opening 2 inches from the front and the back. And probably a lot of you are thinking, oh my gosh, I don't understand what that means. And we've done that to you on purpose because in the real world, when you get out there and you're actually creating an engineering drawing, someone might come in with something literally sketched on a napkin or a piece of paper, and it's always done terribly. And what you have to do is you have to recreate the drawing so a machinist will actually be able to interpret the drawing correctly. So we want you to interpret this drawing. So if you take a look at it, it says end equals 8 inches square. Well, what's another name for the end? Well, the end might be the side. So the side is going to be 8 inches high, and it's going to be 8 inches wide. All right. How wide is the top? Well, the top is going to be 12 inches by 8 inches deep because this side or end was said to be 8 inches square, right? Now we also know that we have an opening in each end of this, right? So if you're reviewing it from this side or you're reviewing it from this side, you would actually see an opening. Now what shape is that opening? Well, I don't see any center lines here, so I know that it's not a hole drilled. Otherwise I would see a center line, but I do see hidden lines. So that would lead me to believe that this shape is going to be a square or a rectangular shape. And it says the opening is 2 inches from the front and 2 inches from the back. So if the opening, and they're talking about the opening of this feature and this feature right here, if the opening from the front and the opening from the back are 2 inches from the front and 2 inches from the back, we know the part is 8 inches square. So if you subtract 2 inches from the front and 2 inches from the back, the width of the part is going to, or the width of the opening rather, is going to be 4 inches, and we know that the opening is 2 inches high. Okay, hopefully that kind of clears up what this part actually looks like before I do the demo. Now down here in the right hand corner it says you're to place the top view here, the front view here, and the right side view here. So we're going to want to line those views up. So you're going to want to redraw this on a scrap or another piece of paper or in a CAD program or in Word or some type of graphical program that you have. If you want to do it by hand, that's great. Just make sure that you use a straight edge, right? We want our views to line up and we want nice crisp lines. So I would start off by redrawing this shape right here, and then I would draw the top view above it, and then to the right hand side I would draw the right hand view, and then right above the right hand view I would draw the isometric. So anyway, that's the configuration that you have to have. So top view, front view, right view, and then in this area right here you're going to want to put the isometric. All right, everyone. Once again, I'm going to use AutoCAD for this demonstration just because it draws nice and clean. You can do it by hand. You can draw it in Word if you want. Any way that you want to do it, as long as you draw it correctly. So here it is. So how long is this line right here? From here to here, how wide was it? Well, if you go back and you look at the assignment, it'll say that it's 12 inches. And the height right here, I think it said that this height was how high? I believe it said it was 8 inches high, and the right hand side or the side of it or the end was 8 inches by 8 inches. So let me draw those two other views for you. So I'm going to see if I can get my AutoCAD working here. Let me see if I can type the word copy. And since it's 8 inches wide, I'm just going to copy this line right here. And then I'm actually going to copy these two lines as well. And then I'm going to copy this one more time. Okay, so I've got the top drawn. So the top, the width of the top is the same as the width of the front. The depth of it, which is how far it actually goes back this direction, is 8 inches because we said the side was 8 inches by 8 inches. So let's go ahead and draw the side now. So I'm going to copy this edge right here. There we go. And then I'll offset this edge right here 8 inches because it's 8 by 8. And then I'll draw my top line here. And I'm going to draw the bottom line on in. Okay, and let's see if this meets the criteria of the assignment number 12. So if you've got your assignment in front of you, it says the end is 8 inches by 8 inches square. So 8 inches high, 8 inches wide, that's 8 inches square. Once again, the front view is 12 inches. That makes the top view 12 inches. And this distance from here to here is the same as this distance from here to here. All right. And notice that all my views line up, right? This edge right here lines up with this one. This edge lines up with this one. This one lines up with this one. And this edge lines up with this one. So far, so good. Now, I know I have a hidden line here and I have a hidden line here. And a hidden line here and a hidden line here. Now, it's probably not necessary to draw both sides of this box. As a matter of fact, the instructions say that you're not supposed to. You're supposed to draw the top view, the front view, and the right-hand side view. But where is this opening right here? Well, if I have a hidden line here and a hidden line here, I know that if I look at this view, I've got a solid line that runs across here, and I've got a solid line that runs across here. So let me go ahead and draw a line. Try it again. I'm going to pick up this hidden line right here, and I'm just going to drag across. And then I'm going to do the same thing with the bottom hidden line. Okay, so I know that that line corresponds to this one, that line corresponds to this one, but I also know that it doesn't extend all the way across because I have some directions that said the opening is 2 inches from the front and 2 inches from the back. Well, this is the front view, which makes this line the front, and this is this would be the back. So I've got the front here with a part, and I've got the back here, and it says the opening is 2 inches from the front and 2 inches from the back. So if I offset this line right here 2 inches from the front, and I offset the rear line, try it again, I'm struggling here. Offset 2 inches. This area right here depicts the opening. So I'm going to trim away the lines that don't need to be there. And so I'm going to use this as a cutting edge, and I'll get rid of this line right here and this one. And then I'll do the same thing down here. Get rid of that. And I'll get rid of that one. And finally, I'm going to get rid of the other two lines that I don't need. So I don't need that, 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 or that. Okay, now I've got my opening drawn, and you can see that this hidden line right here corresponds to this top edge. This hidden line right here corresponds to the bottom edge. It's 2 inches from here to here, and it's 2 inches from here to here. Okay, so what's missing from the top view here? Well, if I've got an opening right here that goes all the way through this part, I need some hidden lines that go all the way through the part. So you need to draw a line from here all the way through this part as a hidden line, and you need to draw a line from here all the way through this part depicted as a hidden line. And then someplace in here is a cutout in the side, right? So you're also going to have a hidden line that comes from here to here, and a hidden line that comes from here to here, and that would depict this line right here and this line. Now, I'm lazy. I've already drawn it here, and I'm going to show you it. So this hidden line right here and this hidden line right here depict this line right here. This hidden line right here depicts this line right here. This hidden line right here depicts this line right here. This line right here is depicted by this hidden line right here. This hidden line, this hidden line, this hidden line, and this hidden line are depicted by this solid line and this solid line here. So anyway, here's all of the hidden lines that you have to have. And the assignment also says that you're supposed to dimension the drawing. So you're supposed to tell me where the hidden lines are and the solid lines. Now typically in the real engineering world you would never dimension to a hidden line, but for the purpose of this assignment we want to make sure that you actually know where the location is. So anyhow, so I need a dimension here that tells me how wide it is. So let me see if I still remember how to dimension. I could go down here and I could click. And if I zoom in, you can see that's 12 inches. All right. So what's the next dimension I might want to put in? Oh, maybe this one. And how high is it? If we zoom on in, you can see that it's 8 inches. Let's go ahead and do the next one. How deep is it here? It's 8 inches, so I'm going to show you that it's 8 inches. How far is it from here to here? Do you remember from the engineering drawing assignment? I think it's 2 inches. So you're going to want to dimension this, maybe from this corner right here to this corner right here, and put that dimension in there. So I might need to stretch this down just a little bit. So let me click here, I'll stretch it down, and then I'll put in a dimension. So I'm going to say dimension from this endpoint right here to this endpoint right here, and I'll pull it on down 2 inches. And then we also said it was 2 inches from the back. Now I could dimension from this corner to here, and that would tell me the location of it, but since it said 2 inches from the front and 2 inches from the back, that's the way I'm going to dimension it. So once again, I'll click dimension here. I'll grab this corner, I'll grab this corner, and I'll drag on down, and I've got 2 inches. Okay. So how high up is this hidden line? Well, we're going to dimension it. So I'll dimension from the endpoint here to the endpoint here, and it's 2 inches. Okay. So you can kind of see what I'm getting at here. You need to dimension all the openings. You could tell me that this is 4 inches wide. It would be an additional dimension. That would be certainly okay, but you don't have to. You're going to want to tell me how big this window is here. How wide is it? So how would you do that one? Well, one way would be to dimension from the corner here to this corner, and then add another dimension in from either this endpoint to this endpoint. Or you could have gone from this endpoint right here to this endpoint right here. I can take 10 inches to subtract 2 from it, and I can come up with 8. So anyway, you need to make sure that you dimension the location of how big it is, where the details are, in other words, where all the cutouts are. You need to dimension the location of the hidden lines, okay, in every view. So I've laid a few of them down here, and I think you have a pretty good idea of how this works. Now, I've gone ahead and I've drawn the isometric for you, and this is what the isometric should look like when you're done. So what is the distance from this point right here to this point right here? Well, if you look here, it should be 12 units. How high should this unit be? This unit should be 8 inches high. How deep should it be? It should be 8 inches deep. So all the dimensions in the orthographic view will help you draw the isometric view. What's the width of this opening? From here to there, it should be 4 inches. And you can see, let me see if it's allowing me to show you. So it's not going to let me do it, but it shows that it's 4 inches. So it's 4 inches wide, 2 inches high. Now you don't have to dimension your isometric, but it does need to be to scale. Okay. Anyway, that's assignment number 12, engineering drawings. Hopefully this has cleared up some of the mysteries of your assignment. If you have questions, make sure that you contact your instructor. Thanks for listening.